All right, let's jump right into this explainer. We're shifting gears from secrets management to something that is absolutely critical, configuration security. We're going to look really closely at how your application behaves out in the wild, because honestly, no matter how bulletproof your code might be, a bad configuration will completely shatter your security posture.
Here is our roadmap for today. We'll hit the unlocked door threat, the default configuration trap, application hardening and headers, secure network configurations, language and infrastructure security, and wrap up with a quick review.
Okay, Section 1, the unlocked door threat, also known as OWASP A05 2021.
So to really grasp the stakes here, let's look at where this sits in the broader landscape. Security misconfiguration is sitting pretty at number 5 on the OWASP Top 10 for 2021. So, it's not some obscure edge case. It's right up there threatening modern apps every single day. We're talking everything from default accounts left turned on, to error messages spilling their guts, all the way down to missing security headers.
The big takeaway here? Attackers don't always need some crazy, complex zero-day exploit when they can literally just walk through a front door you forgot to lock. That's exactly what makes misconfigurations so incredibly dangerous. They are just so easy to exploit. No elite hacking skills are required if you're just leaving default passwords active or broadcasting your internal server versions to the entire internet.
Moving to Section 2, the default configuration trap, or as I like to call it, the false sense of works out of the box.
So why do developers leave these doors unlocked in the first place? Honestly, it almost always starts with defaults. Every framework, database, and server you touch ships with default settings. Think of them like the cheap manufacturer locks on a brand new house. Sure, they let you get inside and start moving furniture, but they absolutely are not meant to keep you safe long-term. These out-of-the-box settings are optimized for a frictionless, super-fast setup experience, and that usually comes at the direct expense of security, leaving things like default admin accounts totally exposed.
To fight back against this, you've got to aggressively harden your systems using a baseline checklist. You absolutely have to change all default credentials and turn off unneeded HTTP methods like trace or options. Make sure you strip out those server version headers, because you really don't want to broadcast your exact tech stack to attackers. Disable directory listing and lock down those secure cookie flags. And always remember the golden rule, the principle of least functionality. If you don't actually need a feature, it's just extra attack surface. Shut it down.
All right, Section 3, application hardening and headers. Think of this as your HTTP-level alarm system. Let's check out one of the easiest ways to get that alarm system up and running. What's super fascinating about this list of HTTP security headers is how they map directly to major real-world threats, giving you massive defense in depth for basically zero implementation cost. Take content security policy. That's your absolute best defense against cross-site scripting. Or Xframe options, which totally blocks click-jocking by stopping your site from being embedded in some malicious iframe. And permissions policy is awesome because it literally dictates whether your site can even request browser features like the camera or microphone. Seriously, turning these on is a huge, quick win.
Next up, Section 4, secure network configurations. It's time to lock down that perimeter.
Moving out to the network edge, the rule here is just undeniably simple. HTTPS is mandatory for every single production endpoint, period. You need to redirect all HTTP traffic to HTTPS using a permanent 301 redirect. On top of that, make sure you're enforcing TLS 1.2 at a bare minimum. The 1.3 is definitely preferred. And completely nuke weak ciphers like RC4 or 3DS. And hey, with tools like Let's Encrypt giving out free automated certificates, there's absolutely zero cost barrier anymore. Unencrypted traffic? There's just no excuse for it.
Now let's talk about CORS, or cross-origin resource sharing. This gets misconfigured all the time. Using the wildcard asterisk is a massive cardinal sin, because you're literally handing a VIP guest pass to the entire internet, inviting everyone straight into your API. Instead, you've got to explicitly whitelist only the specific origins that actually need access. And be sure you're validating that origin header on the server side, not just blindly echoing it back.
Which brings us to Section 5, language and infrastructure security, where we defend the actual foundation.
Looking at the foundation itself, you have to maintain a really strict separation here. Sure, your dev environment is naturally optimized for fast debugging with those nice verbose errors. But your production environment? That needs to be hardened, stripped of chatty logs, and heavily validated. Honestly, if your production config looks anything at all like your dev config, you are looking at a massive red flag. A truly secure app validates its configuration right at startup and fails fast if a security setting is missing, instead of limping along in an insecure state.
And when we look at specific languages and frameworks, the core concepts are identical. Whether you're using Flask Talisman in Python, Helmet middleware for Node, or Spring Security in Java, the underlying architecture of automating headers and whitelisting cores is universal. The specific tools might change, but the security principles definitely do not. Keep your configs externalized, never hard code them, and lean heavily on these battle-tested security libraries.
But wait, configuration security doesn't just stop at your app code, it goes straight down into your infrastructure. You should absolutely be defining your infrastructure as code, but then you've got to proactively scan those definitions in your CI pipeline using tools like tfsec or checkov before they ever deploy. And remember, always scan and fix the underlying template in CI rather than manually tweaking things in the deployed environment. I mean, if you just manually patch an open S3 bucket in the AWS console, your very next Terraform apply is just going to overwrite it and expose it all over again.
All right, let's bring it home with Section 6, Review and Key Takeaways. Let's test your locks.
To wrap up this explainer, let's do a quick interactive review to see what's stuck. Think back to the very beginning. What is the exact OWASP classification for these unlocked doors we've been talking about?
Nailed it! It's A05 2021, Security Misconfiguration. And the key takeaway here is that every single threat in this bucket, from default credentials to missing headers, is fundamentally a totally preventable configuration mistake, not some unpatchable zero-day nightmare.
Okay, next question. Thinking back to our HTTP-level network alarm system, what exactly does the HTTPS header do, and why do we insist on strictly enforcing it?
Right. HTTP Strict Transport Security, or HST, is super important because it stops attackers from intercepting that initial vulnerable HTTP request via an SSL stripping attack. It basically forces the browser to only ever connect via HTTPS, and it's incredibly powerful when you throw in the include subdomains directive and get your site on the browser preload list.
All right, last question. Why should you literally never use a wildcard asterisk for a production core setup?
Spot on! Because a wildcard allows literally any website on the internet to make authenticated requests to your API, which is a fantastic way to expose all your sensitive user data. Always, always whitelist specific trusted origins.
At the end of the day, configuration security is really just about not being your own worst enemy. A perfectly secure application running on an insecure, misconfigured foundation is, well, it's still an insecure application. So, I want to leave you with a challenge for today. What default settings are quietly lurking in your codebase right now? Go find out. Thanks so much for joining me on this explainer, and I'll catch you next time.